Okay, so this is topic 8, function notation. We're going to go through defining a function, so how we determine if it's a function or not a function. Function notation in equations, and then function notation in graphs. Okay. So when we are defining a function, so a function versus not a function, we can look at many different things. So in these examples, we're going to look at maps, and that's what these oval things with the arrows are called, maps. We can look at tables, and we can look at graphs, okay, to determine if something is not a function. The definitions here, we have input. So anytime you see the word input, that means x values. If you see output, that means y values. A relation is a set of inputs and outputs. So if you think of a point, x comma y, that is a relation. I'll write that here. And then a function is defined as a relation where each input has exactly one output. So we could write that in different words by saying that a function is when the x's don't repeat. This means function. So if we were looking at the opposite of that, not a function, that means the x's would what? Repeat. Notice in here I'm not talking anything about the y's. Y's can repeat all they want, okay, and it will still be a function, but x's cannot. Okay. So when we are given maps, the best way to do this is to turn these maps into relations. So we're turning them into points. So every time you see an arrow come off of the x, that tells us that our first point here is going to be 1, 3. Because notice how it's going from the 1 to the 3. Okay. Notice there's another arrow coming from the 1. So what would be that next relation? Okay. And then we just continue that process. So what's the next relation? Good, because we're looking where the arrows are coming off of. And then lastly?
3, -2.
Mm-hmm. So here we're checking if any of the x's repeat.
It's not a function.
Good. So it repeats those 2 times. We have 2 1s. So since it repeats, it is not a function. Okay. Looking at number 2. So in number 1, we noticed we can know that it's not a function right away based off the arrows, right? There was 2 arrows coming off of 1. That means that one is repeated. I don't know why it keeps turning off.
It's always towards the end of the class.
I know. It's telling me it's done. Okay. So looking at number 2, without writing our relations down, is this a function or not a function? Yes. Why is it a function? Good. None of them repeat, because if we look at the inputs, that first oval, we have 1 arrow coming off the 1, 2, and 3. Only 1 arrow coming off, meaning only 1 relation is using each of those x's. So it is a function. Okay. Same with tables. We could take a table and write it in relations. Remember, another word for relation is points. So since we have this table, notice that one column is x, but the other column is f of x. What's another name for f of x? Y. So just know that this is the same as x comma y. So let's go ahead and do the points for this one, and then in the next one we won't do the points. So if our points are always x comma y, what's my first point? Yep, what about my next? Okay, do you see what we're doing here? We're taking the x, comma, the y. X, comma, the y. I'm taking these from the table and turning them into relations, or in other words, points. Once I have these points, I can look at all the x values. Do any of my x values repeat? Nope, so this tells us this is a function. And I could have found that out by just looking at the x column here, right? Okay. None of those x values repeat, so it is a function. What about 4? Everyone agree? Why is it not a function?
X is repeat.
Which repeats? Good, the zeros and the 2s. Okay. So that was maps, tables, and now we're going to look at points on a graph. Okay. There are 2 ways to do this one. So on number 5, we're going to do the longer way, the step-by-step. So here, it gives us all our points, but it doesn't label them. It doesn't say x, comma, y. We're going to have to do that part. So let's go ahead and go through this table and label each one x, comma, y. So starting with A, what is that point? Okay, let me zoom it in for those who don't have that. Good, 5, comma, 3. Okay, what about B? Good, negative 3, 1. C? Good, does everyone see how we're getting these points? D? Good, 0, negative 3. What about E? 0, 0, because it's the origin. And then F? Good, 4, negative 5. And then lastly, G? Yeah, it looks about 6.5. So 6.5, 0. Now we're looking at all the x values. So all those first numbers. Do any of those x values repeat?
Yes.
Which one?
0.
The 0. So what is this?
Not a function.
Not a function. Because these ones repeat. Okay. Let's say you don't want to label the points. Okay. If you don't want to label the points and you still want to check if something is a function versus not a function, you can use the vertical line test. The vertical line test means I'm going to draw a vertical line everywhere on this graph. And since this is not a physical graph that has like the dots connected, I'm going to have to draw even more vertical lines. I'm going to draw a whole bunch just for this example. And I'm just making sure I'm at least crossing through the points. So if this was a function, it would only cross through 1 point. Okay? If this is not a function, then it's going to cross through 2 points. So what is this? Not a function. So this is not a function because it crosses through the S and the T at the same time. So I'm going to say doesn't pass vertical line test, crosses both point S and T. Okay. And in the next examples, I'm going to talk about the vertical line test. That's pretty self-explanatory. You just draw a vertical line, and it cannot pass through 2 points. So, for example, not a function, because it passed through 2 points. Okay? Function, because it only passed through 1 point. So, not a function, more than 1 point. Function, only 1 point. So just doing the vertical line test on number 7, that tells us what? Function or not a function?
Not.
Not a function. Why?
Because the x's are repeated.
Good, because it crosses this ellipse at the top and it crosses at the bottom. Okay, what about number 8?
Yes.
Why?
Because the y's were repeated.
Yeah, but remember, we don't care about the y's, just the x's. So if we were to draw a vertical line, it's only going to pass through 1 point each time. Okay, number 9. Correct. It is a function because it only crossed 1 time. And then lastly, what's number 10 going to be? Not a function, because at any time it's going to definitely cross more than once. So in this one it crosses up to 4 times. So not function. Okay. Any questions on function, not a function? That ends that concept. Function, not a function. Okay. Now we're looking at function notation. So function notation, we use the letter F to name a function. So for example, right here, this symbol, f of x, is said function of x. We don't have to use f though. We could use any variable. So for example, in number 11, we would say this is what? G of x. Good. G of x. Most commonly, f is used, but don't let it throw you off if any other variable is used, any other letter. Okay. So for function notation, we are just plugging in what it's telling us into the equation. So for example, on number 11, we have the equation g of x is equal to 1/2 x minus 1. In part A, it wants us to plug in g of 0. That 0 is going to be what value, x or y? X. So I'm going to plug in a 0 anywhere I see an x. So g of 0 is equal to 1/2 times 0 minus 1. Okay. Correct. So if we were to simplify this, 1/2 times 0 cancels out, and we're left of g of 0 is equal to -1. However, my answer has to be written as a point. So what is this point? Remember, 0 is my x. So it would be 0, comma, -1. That's my answer. Okay, if it's inside the parentheses, so it's g of something, that number inside the parentheses is always your x. So for part B, what are we plugging in for x? 2. So we have 1/2 times 2 minus 1. What's 1/2 times 2? 1. So g of 2, we have 1 minus 1, which becomes 0. So how would I write g of 2 equals 0 as a point? 2, 0. Okay. What about g of 4? What's that 4 representing? X or y? X. So I have g of 4 is equal to 1/2 times 4 minus 1. So that means g of 4 gives me, what's 1/2 times 4? 2, and 2 minus 1? Good, so I have g of 4 equals 1, which is what point? 4, 1. Okay. We're just going to finish off 11, and then we'll do the rest next time. Sorry, we're just finishing off 11. Okay, so -2 is going to be what? X or Y? X. So I have g of -2 is equal to 1/2 times -2 minus 1. What's 1/2 of -2? -1. So -1 minus 1 gives me, so that means that leaves me with the point. Good. What about for E and F? E and F says, what is the value of x if given g of x equals a number? So in this case, are we given x or are we given y? Y. So for g of x equals 10, this is our y value. So we have 10 is equal to 1/2 x minus 1. So we need to solve for x. So what do we do first? Not subtract 1. No. In order to get x by itself, I do need to move that 1 over, but it's already minus. So that means I'm going to add 1. So I get 11 is equal to 1/2 x. And what do I need to multiply x by to get rid of that 1/2? 2. So I get 22 is equal to x. So what is my point? 22, 10. And then last one, number F, says what is the value of x if g of x is equal to 21? 21 is our x or our y? Our y. So I have 21 is equal to 1/2 x minus 1. What's my first step?
Add 1.
Add 1. So I have 22 equals 1/2 x. How do I get rid of that 1/2?
Times 2.
Times 2 to both sides. So I get x is equal to 44, which means my point is what?
21.
Correct. So
That 21 equals 1 over 2x minus 1. That's pretty much y equals mx plus b, correct?
yes, yes. Okay, so that's part 1 of topic 8. We'll finish off topic 8 on Monday and then do topic 9.